Today's lesson is on counting and probability. Arrangements with repetition. If we make R selections from a group of N choices, a total of N to the R different arrangements are possible. For example, how many 7-number license plates are possible? Well, that would be, there's 10 possible numbers between 0 and 9, that is. So 10 to the 7 would be the number of possible license plates. We are dealing with permutations whenever all selections come from a single group of items. No item may be selected more than once, and the order matters. The total number of permutations possible with a group of N is N factorial. That's what that little exclamation mark is. And N factorial means this. Like if 9 factorial would be 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. A middle school principal needs to schedule 6 different classes: algebra, English, history, science, Spanish, and gym, in 6 different time periods. How many different class set schedules are possible? Well, that would be 6 factorial. 6 times 5 times 4 times 3 times 2 times 1. 720 different ways. If we make R selections from a group of N items, the number of permutations is N factorial over N minus R factorial. On a team of 10 swimmers, how many possible 4-person relay teams are there? So that would be N 10 P 4. So 10 factorial over 10 minus 4 factorial. That'd be 10 times 9 times 8 times 7 times, that's supposed to be a times 6 times 5 times 4 times 3 times 2 times 1, okay? On the bottom, I'm just going to write that as 10 factorial again. Let's show you what I'm going to do without having to write all that out. 10 minus 4 factorial would be 6 factorial. So here's the deal. 10 times 9 times 8 times 7 times 6 factorial and 6 factorial cancel out. So all we would need to multiply is 10 times 9 times 8 times 7 to get that there are 5,040 possible relay teams. If an international track event has 8 athletes participating and 3 medals are to be awarded, how many different orderings of the top 3 athletes are possible? So there's 8 athletes and 3 possible medals. That would be 8 factorial over 8 minus 3 factorial, or 8 factorial over 5 factorial. So 8 times 7 times 6 times 5 factorial over 5 factorial. I stopped at 5 factorial because I know that's going to cancel out. So it's just 8 times 7 times 6. 336 different orderings of the top 3 athletes. A Little League manager has 15 children on her team. How many ways can she form a 9-player batting order? So 15 and 9. It'd be 15 factorial over 15 minus 9 factorial. Or 15 factorial over 6 factorial. So that would be 15 times 14 times 13 times 12 times 11 times 10 times 9. I'm going to have to move this. Times 8 times 7 and 6 factorial on the top and bottom would go away. So it's 1,816,214,400 batting orders are possible. A lot. Combinations occur whenever all selections come from a single group of items. No item may be selected more than once, but the order does not matter. If we make R selections from a group of n items, the number of possible combinations is n factorial over n minus r factorial times r factorial. In a committee of 3 people, if a committee of 3 people are needed out of 8 possible candidates, and there's not any distinction between the committee members, there's no order, how many possible committees would there be? Well, out of 8, we need 3. So that's 8 factorial over 8 minus 3 factorial times 3 factorial. Okay, so 8 times, well, let's do this way first. 8 factorial over 5 factorial times 3 factorial. So on the top, we'd have 8 times 6 times 7, 8 times 7 times 6 times 5 factorial. On the bottom, we have 5 factorial, which I'm just leaving it like that because I know it's going to cancel. And then 3 times 2 times 1. So it's 8 times 7 times 6 divided by 3 times 2 times 1. 56 possible committees. Suppose that you select 3 different flavors of ice cream in a shop that carries 12 flavors. How many flavor combinations are possible? So there's 12 flavors. We only need 3. 12 factorial over 12 minus 3 factorial times 3 factorial. So I know the 9 factorials are going to cancel. So I've got 12 times 11 times 10 on the top. And on the bottom we have 3 times 2 times 1. 220 possible flavor combinations. Coincidences are bound to happen. Although a particular coincidence may be highly unlikely, some similar coincidence may be extremely likely or even certain to occur. In general, this means that coincidences should be expected to occur with their likelihoods dictated by the laws of probability. What is the probability that at least 2 people in a class of 25 have the same birthday? So, the answer would be in this form. The probability of at least one pair of shared birthdays would be 1 minus the probability of no shared birthdays. Okay, what's the probability of no shared birthdays? Well, if we use that first reasoning that we talked about with repetition, then the probability that there wouldn't be a shared birthday would be 364 out of 365. This is from the previous section. Then the probability of a second non-shared birthday would be 363 out of 365. The probability of a third not shared birthday would be 362 out of 365. Now that's a lot of ones to go on. But we know that there's only 25 in here. So that would go down to 341 out of 365. So it's 364 times 363 times 362 times all the way down to 341 over 365 multiplied 24 times. That gets us 1.348 times 10 to the 61 over 3.126 times 10 to the 61, which is about 0.431. So this is the probability that there's no shared birthdays. So we wanted the probability of at least one pair of shared birthdays. And that would be 1 minus, as we said a second ago, the probability of none shared. So about 0.569. So there's about a 57% chance of at least 2 people out of 25 having the same birthday.